Welcome. We're here to present on JMessenger, a communication applet that enables secure code sharing between developers. Our team members are Scott Heidelberg, Mitch Herbs, Kayla Lindstrom, Summer Smith, and David Thuralt. So we're going to start by walking through our proposed statement of work.
Okay, so to summarize our current problem, basically, as our company has grown, it has become increasingly difficult for the developers to reliably share and protect their code. So what we're currently in need of is a communications program that will allow the developers to not only share their code on private secure servers, but also allow them to store all the communications into a database, which is what's required in order to meet SOX compliance. So as we look at the risk involved with this, overall we feel that it's relatively low. The new application can be developed in tandem along with the current solution, so that will decrease any potential for loss of productivity. Also, since the new application will be hosted on internal servers and networks, the risk of any proprietary information being lost or compromised is very small as well. Financial obligations are minimized as well, since we'll be using the existing internal developers that we currently have and shouldn't need to outsource any of the project. So putting all that together, we ultimately feel that the potential benefits far outweigh any of the potential risks associated with it.
So basically the purpose of this project is to allow programmers to share proprietary code within a corporate environment. So we can use this within our own environment, and then if we develop the code properly, we were hoping that maybe we could even market it to other companies. The idea is that it will only be used via HTTPS or SSH, which ensures security, and also all code transmissions and communications will be logged in a secure database, which takes the place of immersion software. The software development lifecycle that we thought would be the best fit is agile development. Agile development essentially means that we're flexible. We embrace changes as they come. We work closely with our customers, or in this case, the people who would be using the software, to come up with what they think would be working software. We keep up a sustainable work pace and pay attention to excellence in detail and good design. It also eliminates a lot of the overhead generated by modeling and documentation. Some of our reasons include the fact that our clarity of requirements right now is low. We're still looking into what exactly we need to include in this. The system is really pretty simple. We just need to send messages and receive them and make sure they're secure. For that reason, the reliability of the system is also very important. The Agile approach provides the added benefit of schedule visibility, and it's a good fit for our development team. It allows for flexibility.
All right, for team composition, since we'll be using Agile development, the focus will be on productivity over planning, and therefore the team structure that we'll use will resemble the Scrum methodology. So Scrum meetings and reports take place daily to report each member's progress and problems, and team roles are largely self-organized within the following structure. So the roles would be, first we have a product owner. So the product owner role works as a representative for the client or end user, and the requirements or needs that the software must fulfill. And so because this is a product to be used in-house, the end user will be the company's software developers. So therefore the best person to represent their needs and fulfill the product owner role would be one of our software development managers. Then the next role that would be fulfilled is the Scrum Master. A Scrum Master will be needed to facilitate communication between the team and the product owner. And the Scrum Master focuses on eliminating distractions from the team and resolving any setbacks to progress. And he or she will help the product owner maintain a backlog of new requirements if and when they arise. And the Scrum Master may chair certain meetings to allow the team more time to work and so on. with the rest of the team, essentially it's just the general role of a team member. With a timeline of about 6 weeks, a project effort estimation of about 5 person months, the development team would consist of 4 main team members, and they would have cross-functional skills. So therefore, the team would self-organize with the help of the Scrum Master and all take part in analyzing, designing, developing, and testing as necessary. And the team would report daily to each other and to the Scrum Master. So those are the roles that we would use.
We will be developing our quality and assurance standards with end-user input to determine our performance and effectiveness requirements for JMessenger. With those standards implemented, we will be doing in-process testing to verify that we are meeting those performance output requirements. And there will be stability testing to ensure that we are able to facilitate continuity of service. Some of that testing will include soak testing, stress testing, and spike testing.
Our project management plan involves creating a whole bunch of different tasks, and each task is given a task code, and that helps us create a critical path for our project. And in order to do this, each task is given a predecessor where those are other tasks that must be completed in order to start on another task. Each task has a certain number of days given so that we may be able to track the duration and then the start and finish of the project. Now, our critical path, as you can see at the bottom, is usually the longest path. So those have been identified with red arrows.
So now that we've got an outline of the project, we're just going to briefly go through some of the things that you'll find in the technical support document.
Okay, so in regards to the technical document, to reiterate the main problem, basically the developers do not currently have a reliable method for communicating and sharing code within other developers. So what we need to find is a solution that will allow us to share that code with the developers, as well as save conversations that they may have and store it in a database, a secure database, in order to meet SOX requirements. And ultimately, this also needs to run in an HTTPS or SSH environment. And so here we have the proposed timeline for development. So this shows the initial planning stages all the way through proposed deployment stages.
So here's our use case diagrams. You can see we've got all of the main buttons. You can send, you can receive messages, you can remotely send or receive, and then we've got several menus that the user can select items from.
All right, and here we have the UML class diagram. Basically, is not a whole lot of classes, just the main frame, the main JMessaging frame, and then the other panels that it'll communicate with. That this is kind of the general overview. It's got a lot of stuff in it, but that's essentially it there.
Here is an example of UML sequence diagram for the send button. Detailed sequence diagrams for all of the other actions can be found in the project documentation.
The next diagram that you can see is the UML state diagram, and with this diagram it shows those who are going to help develop the project. If we do go through with this and start implementing, it will go through the buttons that we will have for the user to press, for example, send being one of them, and the events and actions that those buttons will do when the user clicks on them.
So overall, we think that JMessenger is a good investment, will be helpful to the company, and can potentially turn a profit. That's our presentation. Thank you for your time.